Hello everyone, welcome to this lecture in the Building Large Language Models from Scratch series. We have covered 5 lectures up till now, and in the previous lecture, we looked at the GPT-3 architecture in a lot of detail. We also saw the progression from GPT to GPT-2 to GPT-3 and finally to GPT-4. We saw that the total pre-training cost for GPT-3 is around $4.6 million, which is insanely high. And up till now, we have also looked at the data set which was used for pre-training GPT-3, and we have seen this several times until now. In the previous lecture, we learnt about the differences between zero shot versus few shot learning as well. So, if you have not been through the previous lectures, we have already covered 5 lectures in this series, and all of them have actually received a very good response from YouTube, and I've received a number of comments saying that they have really helped people. So I encourage you to go through those videos. In today's lecture, we are going to be discussing about what we will exactly cover in the playlist. In these 5 lectures, we have looked at some of the theory modules, some of the intuition modules behind attention, behind self attention, prediction of next word, zero shot versus few shot learning, basics of the transformer architecture, data sets used for LLM pre training, difference between pre training and fine tuning, etc. But now, from the next lecture onwards, we are going to start with the hands on aspects of actually building an LLM. So, I wanted to utilize this particular lecture to give you a roadmap of what all we will be doing in this series and what all stages which we will be covering during this playlist. So, that is the title of today's lecture, Stages of Building a Large Language Model. Towards the end of this lecture, we will also do a recap of what all we have learned until now. So, let's get started with today's lecture. Okay, so we will break this playlist into 3 stages: stage 1, stage 2, and stage 3. Remember, before we get started, that this material which I'm showing is heavily borrowed from the book Building a Large Language Model from Scratch, which is written by Sebastian Rashka. So I'm very grateful to the author for writing this book, which is allowing me to make this playlist. Okay, so we'll be dividing the playlist into 3 stages: stage 1, stage 2, and stage number 3. Unfortunately, all of the playlists currently which are available on YouTube only go through some of these stages, and that too, they do not cover these stages in detail. My plan is to devote a number of lectures to each stage in this playlist so that you get a very detailed understanding of how the nuts and bolts really work. So, in stage 1, we are going to be looking at essentially building a large language model, and we are going to look at the building blocks which are necessary. So before we go to train the large language model, we need to do the data pre-processing and sampling in a very specific manner. We need to understand the attention mechanism, and we will need to understand the LLM architecture. So in the stage 1, we are going to focus on these 3 things: understanding how the data is collected from different data sets, how the data is processed, how the data is sampled, number 1. Then we will go to attention mechanism, how to code out the attention mechanism completely from scratch in Python, what is meant by key, query, value, what is the attention score, what is positional encoding, what is vector embedding. All of this will be covered in this stage. We will also be looking at the LLM architecture, such as how to stack different layers on top of each other, where should the attention head go, all of these things. Essentially, the main understanding or the main part of this stage will be to understand the basic mechanism behind a large language model. So, what exactly we will cover in data preparation and sampling? First, we will see tokenization. If you are given sentences, how to break them down into individual tokens. As we have seen earlier, a token can be thought of as a unit of a sentence, but there is a particular way of doing tokenization. We'll cover that. Then we will cover vector embedding. Essentially, after we do tokenization, every word needs to be transformed into a very high dimensional vector space so that the semantic meaning between words is captured. As you can see here, we want apple, banana, and orange to be closer together, which are seen in this red circle over here. We want king, man, and woman to be closer together, which is shown in the blue circle. And we want sports such as football, golf, and tennis to be closer together, as shown in the green. These are just representative examples. What I want to explain is that before we give the data set for training, we need to encode every word so that the semantic meaning between the words are captured. So words which mean similar things lie closer together. So we will learn about vector embeddings in a lot of detail. Here we will also learn about positional encoding. The order in which the word appears in a sentence is also very important, and we need to give that information to the pre-training model. After learning about tokenization, vector embeddings, we will learn about how to construct batches of the data. So if we have a huge amount of data set, how to give the data in batches to GPT or to the large language model which we are going to build. So we will be looking at the next word prediction task. So you will be given a bunch of words and then predicting the next word. So we'll also see the meaning of context. How many words should be taken for training to predict the next output? We'll see about that and how to basically feed the data in different sets of batches so that the computation becomes much more efficient. So we'll be implementing a data batching sequence before giving all of the data set into the large language model for pre-training. After this, the second point, as I mentioned here, is the attention mechanism. So here is the attention mechanism for the transformer model. We'll first understand what is meant by every single thing here. What is meant by multi-head attention? What is meant by masked multi-head attention? What is meant by positional encoding, input embedding, output embedding, all of these things. And then we will build our own LLM architecture. So these are the two things: attention mechanism and LLM architecture. After we cover all of these aspects, we are essentially ready with stage one of this playlist, and then we can move to the stage two. Stage two of this series is essentially going to be pre-training, which is after we have assembled all the data, after we have constructed the large language model architecture which we are going to use, we are going to write down a code which trains the large language model on the underlying data set. That is also called as pre-training. So the outcome of stage 2 is to build a foundational model on unlabeled data. Now, I'll just show a schematic from the book which we will be following. So this is how the training data set will look like. We'll break it down into epochs, and we will compute the gradient of the loss in each epoch, and we'll update the parameters. Towards the end, we'll generate sample text for visual inspection. This is what will happen exactly in the training procedure of the large language model. And then we'll also do model evaluation and loading pre-trained weights. So let me show you the schematic for that. So we'll do text generation, evaluation, training and validation losses. Then we'll write the LLM training function which I showed you. And then we'll do one more thing. We will implement functions to save and load the large language model weights to use or continue training the LLM later. So there is no point in training the LLM from scratch every single time, right? Weight saving and loading essentially saves you a ton of computational cost and memory. And then at the end of this, we'll also load pre-trained weights from OpenAI into our large language model. So OpenAI has already made some of the weights available. They are pre-trained weights. So we'll be loading pre-trained weights from OpenAI into our LLM model. This is all what we'll be covering in the stage two, which is essentially training loop plus model evaluation plus loading pre-trained weights to build our foundational model. So the main goal of stage 2, as I told you, is pre-training an LLM on unlabeled data. Great, but we will not stop here. After this, we move to stage number 3. And the main goal of stage number 3 is fine-tuning the large language model. So if we want to build specific applications, we will do fine-tuning. In this playlist, we are going to build two applications which were mentioned in the book I showed you at the start. One is building a classifier and one is building your own personal assistant. So here are some schematics to show. So if you want to, let's, you have got a lot of emails, right? And if you want to use your LLM to classify spam or no spam, for example, you are a winner, you have been specially selected to receive $1,000 cash. Now this should be classified as spam, whereas, hey, just wanted to check if we are still on for dinner tonight, let me know. This will be not spam. So we will build a large language model, this application which classifies between spam and no spam. And we cannot just use the pre-trained or foundational model for this, because we need to train with labeled data. To the pre-trained model, we need to give some more data and tell it that, hey, this is usually spam and this is not spam. Can you use the foundational model plus this additional specific labeled data set which I have given to build a fine-tuned LLM application for email classification? So this is what we'll be building as the first application. The second application which we'll be building is a type of a chatbot which basically answers queries. So there is an instruction, there is an input, and there is an output, and we'll be building this chatbot after fine-tuning the large language model. So, if you want to be a very serious LLM engineer, all the stages are equally important. Many students, what they are doing right now is that they just look at stage number three, and they either use Lang chain, let's say, they use tools like Olama, and they directly deploy applications, but they do not understand what's going on in stage 1 and stage 2 at all. So this leaves you also a bit underconfident and insecure about whether I really know the nuts and bolts, whether I really know the details. My plan is to go over every single thing without skipping even a single concept in stage 1, stage 2, and stage number 3. So this is the plan which we will be following in this playlist, and I hope you are excited for this, because at the end of this, really, my vision for this playlist is to make it the most detailed LLM playlist, which many people can refer, not just students but working professionals, startup founders, managers, etc. And then you can, once this playlist is built over, I think 2 to 3 months later, you can refer to whichever part you are more interested in. So people who are following this in the early stages of this journey, it's awesome, because I'll reply to all the comments in the um, chat section, and we'll build this journey together. I want to end this lecture by providing a recap of what all we have learned so far. This is going to be very important, because from the next lecture we are going to start a bit of the hands-on approach. Okay, so number one, large language models have really transformed the field of natural language processing. They have led to advancements in generating, understanding, and translating human language. This is very important. So the field of NLP, before, you needed to train a separate algorithm for each specific task, but large language models are pretty generic. If you train an LLM for predicting the next word, it turns out that it develops emergent properties, which means it's not only good at predicting the next word, but also at things like multiple choice questions, text summarization, then emotion classification, language translation, etc. It's useful for a wide range of tasks, and it's that has led to its predominance as an amazing tool in a variety of fields. Secondly, all modern large language models are trained in two main steps. First, we pre-train on an unlabeled data. This is called as a foundational model, and for this, very large data sets are needed, typically billions of words, and it costs a lot. As we saw, pre-training GPT-3 costs $4.6 million. So you need access to huge amount of data, compute power, and money to pre-train such a foundational model. Now, if you are actually going to implement an LLM application on production level, so let's say if you are an educational company building multiple choice questions, and you think that the answers provided by the pre-training or foundational model are not very good and they are a bit generic, you can provide your own specific data set, and you can label the data set saying that these are the right answers, and I want you to further train on this refined data set to build a better model. This is called fine tuning. Usually, airline companies, restaurants, banks, educational companies, when they deploy LLMs into production level, they fine tune the pre trained LLM. Nobody deploys the pre trained one directly. You fine tune the LLM on your specific smaller label data set. This is very important. See, for pre training, the data set which we have is unlabeled, it's auto regressive, so the sentence structure itself is used for creating the labels, as we are just predicting the next word. But when we fine tune, we have a labeled data set, such as, remember the spam versus no spam example which I showed you? That is a labeled data set. We give labels like, hey, this is spam, this is not spam, this is a good answer, this is not a good answer. And this fine tuning step is generally needed for building production ready LLM applications. Important thing to remember is that fine tuned LLMs can outperform only pre trained LLMs on specific tasks. So let's say you take two cases, right? In one case, you only have pre trained LLMs, And in second case, you have pre-trained plus fine-tuned LLMs. So it turns out that pre-trained plus fine-tuned does a much better job at certain specific tasks than just using pre-trained. For students who just want to interact for getting their doubts solved or for getting assistance in summarization, helping in writing a research paper, etc., GPT-4, Perplexity, or such API tools or such interfaces which are available work perfectly fine. But if you want to build a specific application on your data set and take it to production level, you definitely need fine tuning. Okay. Now, one more key thing is that the secret sauce behind large language models is this transformer architecture. So, the key idea behind transformer architecture is the attention mechanism. Just to show you how the transformer architecture looks like, it looks like this. And the main thing behind the transformer architecture, which really makes it so powerful, are these attention blocks. We'll see what they mean, so no need to worry about this right now. But in a nutshell, attention mechanism gives the LLM selective access to the whole input sequence when generating output one word at a time. Basically, attention mechanism allows the LLM to understand the importance of words, and not just the word in the current sentence, but in the previous sentences which have come long before also, because context is important in predicting the next word. The current sentence is not the only one which matters. Attention mechanism allows the LLM to give access to the entire context and select or give weightage to which words are important in predicting the next word. This is a key idea, which and we'll spend a lot of time on this idea. Remember that the original transformer had only had encoder plus decoder, so it had both of these things. It had the encoder as well as it had the decoder. But generative pre-trained transformer only has the decoder. It does not have the encoder. So transformer and GPT is not the same. Transformer paper came in 2017. It had encoder plus decoder. Generative pre-trained transformer came 1 year later, 2018, and that only had the decoder architecture. So even GPT-4 right now, it only has decoder, no encoder. So 2018 came GPT, the first generative pre-trained transformer architecture. 2019 came GPT-2. 2020 came GPT-3, which had 175 billion parameters, and that really changed the game because no one had seen a model this large before. And then now we are at GPT-4 stage. One last point which is very important is that LLMs are only trained for predicting the next world, right? But very surprisingly, they develop emergent properties, which means that although they are only trained to predict the next world, they show some amazing properties like ability to classify text, translate text from one language into another language, and even summarize texts. So they were not trained for these tasks, but they developed these properties, and that was an awesome thing to realize. The pre-training stage works so well that LLMs develop all of these wonderful other properties, which makes them so impactful for a wide range of tasks currently. Okay, so this brings us to the end of the recap which we have covered up till now. If you have not seen the previous lectures, I really encourage you to go through them because these lectures have really set the stage for us to now dive into stage one. So, from the next lecture, we'll start going into stage one and we'll start seeing the first aspect, which is data preparation and sampling. So the next lecture title will be working with text data, and we'll be looking at the data sets, how to load a data set, how to count the number of characters, how to break the data into tokens. And I'll start sharing Jupyter notebooks from next time onwards so that we can parallelly begin coding. So thanks everyone. I hope you are liking these lectures. So lecture 1 to 6 were kind of like an introductory lecture to give you a feel of the entire series and so that you understand concepts at a fundamental level. From lecture 7 we'll be diving deep into code and we'll be starting into stage 1. So I follow this approach of writing on a whiteboard and also coding, so that you understand the details plus the code at the same time, because I believe theory plus practical implementation both are important, and that is one of the philosophies of this lecture series. So do let me know in the comments how you are finding this teaching style, because I will take feedback from that and we can build this series together. 3 to 4 months later, this can be an amazing and an awesome series, and I will rely on your feedback to build this. Thanks a lot everyone, and I look forward to seeing you in the next lecture.